This lesson we're going to talk about normal distributions and box plots. For the normal distributions, when we're talking about mean, we're going to use this mute sign for the means. And for the standard deviation, we're going to use the sigma for the standard deviation notations. In order to be a normal distributions, you need to follow these rules. So the first one is going to be, the mean is going to be exactly half. So the second one is also saying that, so if you draw the lines through the means, the right side and left side is going to be symmetries. And the curved line never touches axis. This one, look, it does, but it is not, right? It should have little gaps between. And then, what else was it? The area under that normal distributions curve should be 1. So inside of this normal distributions, there is a probabilities, right? That's why the whole thing, the area is equals to 1. So when you cut it in half, let me just do that. If you cut it in half like that, this side is going to be 0.5, this side is going to be another 0.5, because from here to here should be equals to 1, the area. This also shows if it's a normal distributions, one standard deviation between one standard deviation between one standard deviation means is going to be 34.13%. So from first standard deviations to the other first standard deviation is going to be 68.26, right? And second standard deviation to second standard deviations, the negative side to positive side, it will be 95.44. The between third standard deviation is going to be 99.72% of the area. Okay. And here is the formula, how to find the z-score using mean and standard deviations. Okay, let's look at example 1 and see how we're going to use this normal distributions to find the probabilities. So here you have find the given area under the standard normal curve. The area between z equals to 0 and z equals to 1. So let me enlarge the graph a little bit. So when it says z equals to 0, it means it starts from the means to z equals to 1. So they want you to find the area between these two, right? How do we find the area between these two? Well, using the table. I import the table from the internet, and there's some different normal distributions graph if you're going to research the graph from the Google browsers. This one right here, it kind of shows the area it's shown under is going to be from mean to the point. So since this one is starting from mean to the points, you're going to do, that point is going to be 1, right? So it will be 1.0. So this is going to be 1.0. So that value is going to be, if you have 1 point, let's say if you have a 0.15, then you're going to do 0.15, then that will be right here. So the tens units, and this is going to be hundreds units. So it will be 0.15 will be this value right there, okay, because it's under 5 in hundreds units. But right now we're looking for when z is equals to 1.0, so it will be 1.00 will be that value. So the area under those two, between those two, z-score is going to be 0.3413. So let me write that down. So this right here is going to be 0.3413. What does that mean? That's the probability. And if you wanted to change it to percent, this means moving decimal 2, so it'll be 34.13%. But again, they're asking you to find the value. They didn't mention anything about being a percentage. What about the next one? Next one, find the area between z equals to 0 and negative 2.43. So if you're looking at this chart, you can see that you don't have any negative numbers, right? But remember, when we're talking about normal distributions, the left side and right side is going to be the same amounts, right? So if we can look for something under positive 2.43, right, this area, this should be the same area as the other area, this area. So we don't have to worry about looking for negative value. We can just look for positive, because from mean to that area is going to be equals, right? So this is going to be same. So then if we look for 2.43, 2.4 and 0, 1, 2, 3. So this is 2.3, right? That gives you 0.4925. So since this area right here is 0.4925, the other side should be the same. And that's how you're going to find the probability once you have a z-score. Let me look at one more. What about this one? This one is not starting from the mean. It says start from negative 0.88 all the way to 2.35. So since this table right here is giving the value from mean to the values, what you need to look for is you need to look for this area plus this area, right? Again, I'm talking about area, so let me erase that. So since the table only gives from mean to the points, you wanted to find this area first, and then find this area and add them up, right? So area under, let me do with the red, 2.35, 2.3, and 5. 0, 1, 2, 3, 4, 5 will be that number. It's going to be 0.4906. And then this area right here is going to be same thing as the area under positive 0.88. So you have 8 and 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be 8. 8 will be 0.3106, right? So you're going to add those two numbers. So the blue area right here is going to be 0.3106, and plus the red area under the table is going to be 0.4906. When you add them up, that will be the total area. So that will make it 12 and 1, 91048. So it will be 0.8012, right? That will be the probability of that area. Let's look at another one. It's a area between 0.58 and to 1.94. So the area that, if I'm looking for area under the table right here for 1.94, they're going to give the area from here to here, right? But then we're not starting from mean, we're starting from 0.58. So what I need to do is I need to subtract this area this times. Then I will get the area of the red. So I'm subtracting this time, right? So the red area, 0.94. Let's see, 1.9 is right here. 4 will be right there, which is 0.438. And subtracting 0.58. 0.58 should be right here, which is going to be 0.2190. So this blue area, I'm subtracting from the full red, which is from mean to the z-score, in order to get only this little corner from the red area. So I'm doing the red, which is 0.4738, and minus the blue area is going to be 0.2190, and this is going to be equal to 0.2548. So that's the area under the area between 0.58 to 1.94. What about C? What about this times you're looking for area from z-score to the right side? When you're looking at this chart right here is showing between mean to the score, not on the other side. We should be able to still find the other side, because remember the normal distributions? Normal distributions, you have half and half. So let me write that down. So if you have whatever you have, the value is from here to here, right? The area values from the table. But if we know from here to there, let me do that with blue. So from here to there is going to be 0.5, right? Or from here to here, mean to the right side is 0.5, mean to the left side is 0.5. And so if we can find the black area, subtract from 0.5, which is the whole right side, then we should be able to get the red area, right? So we're doing 0.5, which is the half, and minus black area. Black area is the z-score 2.09. So let me move this a little bit. 2.09 is all the way in. It will be 0.4817. So you're going to subtract that. 0.4817. This is going to give you the red area, which is 0.0183. And on the notes, class notes, you will see from the full graph how am I figuring out those little area. Again, from the half, subtract this area, right, to find this. So far, if we have a z-score, this is how we're going to find the probabilities using this normal distributions table, right? But what about if the mean and standard deviation is given, but you don't have a z-score given? So if you don't have a z-score given, then you're going to use the formulas. So let's look at the first example of 3. It say the normal distributions had mean of 60, standard deviation of 5. Find the z-score. Find the z-score when x is 65. So that's the part A. In order to find the z-score, you're going to plug into the formula, which is the value, given value minus the mean over standard deviations, which is 5. So again, your formula is value minus mean over standard deviations. And this is going to give you 5 over 5, which is going to be 1. What about if you have value as 52.5? 52.5 minus still mean over standard deviation. This gives me negative value 7.5 over 5, which is going to be negative 1.5. If you have a z-score 1 or z-score negative 1.5, when you're graphing it in normal distributions, you can tell positive number is going to be on the right side of your mean, and the negative number is going to be the left side of your mean, right? And you can tell it's smaller than mean, larger than mean, right? So now we're going to look at the word problems and see how actually we're going to use this normal distributions into the real life problems. It's a manufacturer proceed product light bulb with the life expectations that are normally distributed with mean of 500 hours and standard deviation of 100 hours. What percentage of the light bulb can be expected to last between 500 to 670 hours? So because it's a normally distributes, I'm going to draw the normal distributions graph. And see what they're talking about. And it's a your mean is going to be 500. And then standard deviation is 100. They wanted to know the percentage between 500 to 670. So it means the order to find percentage, we wanted to find the probability first. Probably means that we wanted to find the area values, right? In order to find the area value, we need to know what this 670 converted into z-score, so we can use the table, right? So your z-score is going to be given value minus mean over standard deviations. This gives you 170 over 100, and that's about 1.7. So your z-score is 1.7. And if we go back to the table, 1.7, it will be right here, 1.7, which is going to be 0.4554. That will be the area under. So in other words, that's the probability of the area. So will be percentage will be 45.54% of the light bulbs will be expected to last between 500 to 670s. Okay, let's look at another one. Example 5. Example 5, this is the salesperson driving. Average, which is the mean, is going to be 1,200 miles. Standard deviation of 150. They want you to find out the probabilities that the salesperson drive between 1,200 to 1,600. For part A, part B is between 1,000 to 1,500. So let's look at the first one. First one, let me draw the normal distributions, and this is going to be standard deviation of 1,200, the mean of, right? Standard deviation was 150. They wanted to know between 1,200 to 1,600. So this is the probability area they want you to look for. So let's see if we can find the z-score for 1,600. It will be z equals to 1,600 minus the mean over standard deviations. That gives you 400 divided by 150, about 2.666 repeating, so it will be 67 maybe, right? On the table, you only had 2 decimals, so rounded to 2 decimals. And when you look at the table, let me bring the table. It will be 2.6 right here, and 7, right? Will be the value of it. So it looks like it's 0.4962. If this is too small, I can make it bigger, and you can see that number is right there, 0.4962, right? So the area right here is going to be 0.4962. That is your probabilities. What about B? This time, mean is 1,200, but they want you to find between those two values. So 1,000 should be smaller than 1,200. And then you have 1,500. So look like you need to find 2 areas. One on this side, that area, and one on the other side, which is going to be same thing, right? So let's find the z-score for the both. So z-score for 1,500 minus mean divided by standard deviations, you get 300 divided by standard deviation, which is going to be 2. And then z-score for 1,000 minus 1,200 divided by that is going to be negative 200 divided by 150, which is equals to negative 1.33 repeating. But remember, the negative value will give you the same area as the positive value. So that will be blue area z value. So the 2 will give me, where's the 2? This area, 0.4773. And 1.33 is this number right here, will give me 0.4082. So when you add those two, so this is going to be 0.4773, and this area is going to be 0.4082. When you add them, 0.4773 plus 0.4082, you will get the total area of 0.8855. So that will be the probability between 1000 volt to 1500. Not the volt. This problem is not the volt one. This is the driving one, right? So cell person will drive between those 2 miles. And that's how you're going to use normal distributions to find out the probabilities or the percent